Hi, everyone. Welcome. I'm Annabelle Weldy from BioBuzz, and very excited to have you guys all here for another one of our Career Catalyst sessions. Today, we're diving into our research track, which is one of 4 new tracks for Career Catalyst. This is the last one that we'll be introducing. And this week for this session, we're going to be focusing on a topic that's central to advancing science. So looking to kind of break down silos and collaborate across disciplines in order to make research fundamentally better. And we're joined by Gautam Kumar, who's a neuroscience with a PhD from University of Maryland, Baltimore, and soon starting a postdoc position at NIH. And Gautam's work combines computational biology and translational neuroscience to tackle neuropsychiatric disorders. So he's going to be kind of talking around this topic today. So feel free to kind of ask questions at the end of his presentation and put those in the chat and we can kind of go through that. Before we do get started, do want to give a quick thank you to our 2 sponsors. So we have BioTrack. That's one of the sponsors for today, and we'll be aligning this research track with that, which this research track, like I said, will be led by Gautam. So BioTrack, they have a lot of the upskilling workshops. They've trained over 17,000 scientists. Highly recommend checking them out if you're looking for upskilling opportunities. Workforce Genetics is our other sponsor for today's session. They've been connecting life science talent with high-performing teams for a while, so definitely check that out at workforcegenetics.com. And also want to mention that today's session is part of the BioBuzz Talent Lab, so we're still in the beta testing of that. But it's your hub for career growth, job opportunities, and industry connections. So if you're not already part of it, would love to have you guys all join. All right, now I'll hand it over to Gautam.
Hi. Okay, so as mentioned, my name is Gautam Kumar, and I'm a neuroscientist. I just received my PhD in neuroscience not just a few months ago at the end of 2025. And within this kind of multidisciplinary multifaceted field, my expertise I specialize in computational biology. Essentially, what my work involves is trying to understand neural processes by analyzing different levels of observation from the molecular level to the cellular level, all the way to the expression of behaviors. And the objective of this kind of research, where it leads to, is the identification of predictive biomarkers that would help us detect the onset of or the risk for these kinds of condition at an earlier time point, so we can introduce interventions and to develop candidate treatment options to improve on the options that are available for a lot of these disorders, like major depressive disorder and substance use disorders that are available now, many of which are associated with a lot of adverse side effects. So how I kind of got into this field has been a bit roundabout. I received my early education in Korea. I was born and raised in Korea to Indian parent. And I went to international school with an American preparatory school that trains people from all over the world to come pursue their higher education in the US. And when I came here, I majored as a neuroscience major as an undergrad. And I enjoyed it so much that it bumped me from being like a okay student in high school to a pretty decent student in college. And I knew that I wanted to kind of pursue this line of inquiry, but the problem was that, as I mentioned, neuroscience is such a multidisciplinary field that it was kind of difficult to decide which trajectory to pursue. So to figure out what I wanted to do, I spent a few years wandering. I completed my master's in the UK, where I picked up my skills in data analysis and statistics. And I completed an MPH here in the States, where I spent time working as a data analyst across a lot of different labs involved in epidemiology, psychiatry, psychology, neuroscience, kind of in the effort to decide where I want to concentrate my effort towards. So ultimately, I decided to pursue my doctoral studies in neuroscience at the University of Maryland, which brings me to where I am today, getting ready to start my postdoctoral work within a few weeks. So one thing you could kind of see from my experience is that I've had the privilege of being exposed to people from a lot of different backgrounds, fields, experiences, and expertise. And this is really hammered into me the importance of using different perspectives and approaches when solving problems. So for this presentation today, what I want to focus on is the value of collaboration between different types of people with different expertise and viewpoints in and where it can provide you, what it can help you in your own development and growth. And over the course of this presentation, I'll be giving examples from my experience, which might be specific to neuroscience, but I intend for the main takeaways to be applicable across different fields and not just in academia. So to start off, I want to talk about something that you see often, not just in research, but across a lot of fields, and that's compartmentalization. And as human beings, it's important that we compartmentalize. We have this tendency to do so because we have to navigate these complex environments in order to understand how to get to whatever goal it is that will increase our likelihood of survival, whether it's food or water. So compartmentalization is useful to us, but it can get in the way when in some aspects of our life, including in our training. The way we train people is highly compartmentalized. If you're taking the example of neuroscience, there are people who are experts at the genomic or molecular level, people who are experts at the circuit level or in behavioral neuroscience. And all these people do incredible work and their work is incredibly valuable. And there's a lot left to do within these fields. But if you take the nervous system as a whole, you can see that alterations in the molecular level will change properties of a neuron, which will result in changes in circuit activity, which would ultimately lead in changes in behavioral expression. The point being that you can't really take these levels into isolation. And when you do, what ends up happening is that you create blind spots. And the consequences of that is that you have a lot of redundancies, a lot of people developing the same kind of tools in different fields, misinterpretation because people don't have an understanding of the developments in fields that are adjacent to theirs, and altogether just slower progress and lower quality of research output. And to kind of support this argument, where we tend to see progress in research or anywhere is at the intersection of different fields. And that's what kind of brings me to my first point, which is that complex problems require cross-training. And as mentioned, milestones in research take place often at the intersection of different fields. And you could see this across the history and the spectrum of neuroscience research. The early pioneering studies that helped us understand basic properties of neurons, how they function and so forth, they were developed by people who were experts in physiology and biology, but they needed a deep understanding of physics in order to understand how signals propagate. Moving to the field of medical neuroscience, the development of tools, diagnostic tools such as the fMRI machine, it required a lot of expertise in neuroanatomy, but it wouldn't have come about if we didn't have engineers collaborating with the people in neurobiology. And a more contemporary and recent example is CRISPR, which is a tool that's extensively used now in neuroscience as well as other biomedical fields. And this was something that was developed by microbiologists and virologists. So this is all just to say that what my experience has shown me is if you want to be get ahead in your field, get those extra dimensions to your capabilities over others, it's more important to be well-rounded and versatile than it is to be the best at something. And one example of how cross-training can help is from my own personal experiences, applying knowledges and tools from one field and into others. And so my example is there's a technique that I learned while I was completing my master's in psychology called factor analysis. I'm not going to go into detail at what it does, but if you imagine a survey or a questionnaire that's designed to measure something that's difficult to directly measure, you see this a lot. Either tests that are supposed to measure a personality trait or intelligence, or in this example over here on the right, the perception of customers of a restaurant. What factor analysis allows you to do is to look at the relationship between each of the independent variables and use that to kind of calculate a measure for the unobserved variable. So in this case, for the evaluating the restaurant, it would be cleanliness and food quality. But you could kind of see how this can be applied in different fields, because it's not unique to psychology to have complex data that are measuring abstractions. So I was able to kind of learn this technique while I was receiving my training in psychology and apply it later on while I was completing a project for public health, looking at the role of religiosity and health outcomes. And in the dissertation that I just completed not too long ago, where I used factor analysis to look at social behavior in mice that underwent chronic stress exposure. And this is all just to show that one technique I learned from a stat class about 10 years ago allowed me to produce results across 3 different fields, and which just goes to highlight the value of cross-training. So it's understandable that it can be difficult to find the resources that you need to get that extra dimension to your work. But the good thing is that now, with so many opportunities to communicate being readily available, with all the different mediums of communication available, there are more and more resources that can help you get that training. And one of which is the sponsors, one of the sponsors of this talk, BioTrack, which is a platform that provides training resources for anyone who's interested in developing lab skills, with workshops from everything including tissue culturing all the way to next generation data sequencing analysis. And it's through using resources like this that I was able to get that cross training I needed to become more well-rounded. So moving on to the second point, it's imperative that you learn from the people around you. What I've observed, what I've learned in my experience is that the skills and attributes that you require to be successful wherever you are so context dependent and specific to you and those around you that you'll never find any sort of clear guideline telling you what you need to get better in, how, and where to look for opportunities. So what's left for you to do is to kind of reverse engineer your success by looking around you where you are and seeing what kind of aspects or traits of the successful people help them become successful, and conversely, what traits or qualities of unsuccessful people contribute to their lack of success. And in my personal life, as I mentioned, I've had the privilege to work with a lot of different kinds of people. So just by watching my fellow students, postdocs, professors, I was kind of able to pick up on things that distinguish those who were successful from those who were less successful. And to my surprise, it never ended up being things like being hard skills like being able to regurgitate information or understanding high level concepts, but things more like organizational and interpersonal skills. And seeing that in action was invaluable to me, and it's the kind of knowledge that I know will be helpful for me going forward when I go to the next stages of my career with more responsibility. And this kind of points to another point, which is that it's important to be surrounded by the right people, because it's the people around you who will drive your growth, your development. So, this becomes more and more relevant as you progress through your career and get to the managerial stage, where you're starting to kind of figure out where you get to shape more and more the people that you work with. And that's where workforce genetics helps. This is a recruiting and talenting solution firm that helps people find the right kind of talent to drive personal growth and professional growth in the workplace and create an organizational culture conducive for innovation and long-term success. And again, in my experience, having had the privilege to work in a lot of different labs, what I've kind of taken from my experience is that the individual capabilities of the researchers are not as important as kind of how they work together and cooperate with one another, which makes finding the right workforce for your organization critical. So moving on to my third and final point, different perspectives and creates depth. So no research or health or scientific problem or any problem in general is one-dimensional. Even addressing something that's seemingly as simple as a common seasonal cold requires you to understand how viruses are mutating, understand population distributions in the city, socioeconomic factors, because simply developing a cure alone isn't sufficient to deal with different variants, outbreaks that take place due to inadequate housing facilities in poor neighborhoods. So if you want to save time and arrive at the most effective and efficient solution, you're going to need to use expertise from across the spectrum. And good and possibly overused analogy of this is trying to solve a jigsaw puzzle. You need to understand where the pieces fit in to get into its big picture in order to solve a jigsaw puzzle. And if you have separate fields, each holding their own piece to this jigsaw puzzle, not communicating with each other, the most you can get out of that are detailed insight into what each piece of puzzle piece looks like. So, taking an example that's outside of neuroscience, asthma is a condition that we all know is manageable through medication, but in order to address it adequately, it requires more than simply opening up the airways. You also need to consider a person's local environment, the traffic density, neighborhood air quality, mold exposure. You also need to account for interpersonal issues such as health literacy at home or in school, and individual differences such as allergen sensitivity and personal habits. In short, to develop the depth and understanding required to address a health issue like this, you require different perspectives. So to close this, I understand it might be challenging to see what sort of actionable advice, actionable insight can be taken from the talking points I just mentioned. So to conclude, I'm going to try to reframe my takeaway as centering around making yourself adaptable. And what it means to be adaptable is to be able to make adjustments that respond successfully to your environment. And that's something that's not built in, innate, but developed through experience. So how do you make yourself adaptable in your field? Well, you do it by looking for opportunities to keep yourself relevant in your field's needs by building unique skill sets, taking advantage of the valuable lessons from experience, whether they're yours or and do all these things is by finding ways to engage with people from different fields and different backgrounds. And thank you. I'll answer questions now.
Awesome. Yeah, thanks for going through that. Now we're kind of entering the Q&A portion of today's session. So yeah, everyone feel free to put questions in the chat. I have a couple of questions for you, Autumn, but you can use, like I said, the chat function to ask those, use the raise hand function, and I'll be helping to kind of moderate them. Yeah, so I like that you kind of were able to, take kind of the information and the skills and, the research that you do as a scientist, and then kind of translate that into these skills that can really help anyone kind of within their career. That was really great. One of the things I think you talked about was approaching problems. So I'd love to know, I guess, what, thinking about like learning, what's one mistake that ultimately improved how you approach problems and problem solving?
That's a good question. I made a lot of mistakes, both in professional and personal life. The one that kind of comes to mind is like while I was working on finishing my first paper, I was just doing the thing that I got used to doing, just analyzing over and over again, waiting to see a result. And so it took much longer than it needed to be to get that completed. And what I learned from that is that while I was working on this paper, everyone around me was giving me pretty good advice that I ended up taking much later, namely like to focus on, rather than analyzing all the data, just making a good story and then working backwards from there. And if I had listened to that kind of advice initially, I would have saved about a year or two in my work. So that's why in this presentation, I kind of hammered down on the importance of listening to people, because I have not listened well throughout my life. And now I'm kind of starting to realize the importance of that. So I think that lesson was critical to me.
Yeah, that's great. And are there any other ways in your career, like instances where you felt like you were able to kind of tap into, maybe like a mentor or like use networking or anything like that that helped you kind of advance?
Oh yeah, my whole career was shaped by advice from other people and resources. Like the one that first comes to my mind is like all my professors were super supportive of me to the extent that like it just motivates me to be more supportive when I get my own people. But they're the ones who told me it wasn't just good advice. They told me exactly what I needed to do to, let's say, get into a PhD program or to, as I mentioned, just complete an assignment like a paper. But, also just like paying attention to just what happens to other people in their life. When you see someone who does something that you wish you could do, receive accomplishment that you wish that you can do, like just getting into the habit of thinking about, how their qualities and their traits kind of help them get to where they are. And going back to the presentation I just made, that's how I kind of realized that it matters more that you're well organized and you have a systemic approach than it does that you're able to understand high level concepts, because the people who are well organized and have clear objectives and plan out their steps are going to produce more than you ever will, no matter how smart you are.
Yeah, that's great. And I kind of have a related question. So obviously today's session is really about breaking down silos and thinking about, developing those interdisciplinary skills and cross-training. So James asked, do you have a mentor? Did you have a mentor or professor that encouraged you to receive cross-training? And did you kind of see evidence of cross-training in the research that you were exposed to?
I had a lot of professors who helped me with my cross-training. My PhD advisor, Professor Mary Kay Lobo, some of the professors I worked with while doing my MPH, Dr. David Salzer and Dr. Tal Nuriel. But actually, this is the most interesting part of it, and it kind of helps support some of the points I made during the presentation. The person who made it clear to me that I should, put some effort into developing my skills as a computational biologist in research was my friend, Dr. Jordan Kunkel, who was doing my MPH at the same time that I was. So we were in like similar stages of our career, but he had already gotten his PhD. And he basically told me that, okay, every lab needs someone who analyzes their data, and scientists tend to hate doing statistics. And so that was another valuable lesson. Like if you want to figure out how to be useful to people, try to find what's scarce and what everyone needs. And yeah, so that was advice from no one who was like in any like particularly high status position, but really shaped my career. So advice can come from everywhere. Just listen to everyone. Don't make the mistakes I have. Just pay attention to when people are talking to you.